graph page. You need one graph. You need more than that. Anya, are you ready? Right, you'll need one graph page. Hi, Mom.
What do you have?
Everybody have one? Everybody have a graph page, right? Yeah? You could stick going to one. Huh? Yeah, run out graph page. All right. So let's begin. So today we want to focus on lenses. Last day we finished up we finished up the phenomena of wave, reflection, refraction, diffraction, interference, right? We went through those four things and waves on the roof. All right. And you had to do some homework for what I didn't do. You wasn't online last week? Or in chat on Tuesday class?
Yeah.
Okay. Right, so this week coming up here, no Saturdays, we'll be doing it this, right? I will send you a reminder, right? Ready? All right, so if you look here, we have two types of lenses, right? For those of glasses, you have a particular type of lens. And the two types of lens that you can have is a convex lens or a concave lens, right? So your lens will be, see when rays coming to your lens here, the lens in blue, your lens will either do two things. It will make all the rays converge to one point, or it will make them move away. All right. So your lens will be doing two things. When a ray comes in here, it will push the ray into what we call a focal point, or the ray will come here and push the ray out. Right? So you have two types of lens: convergent lens that bring in all the rays together, and divergent lens that push it all away. That's okay? Right? Divergent lens is called concave lens, and converging lens is called convex lens. So because of it, don't do all the homework, draw that from now. Draw the two lenses, concave and convex. Right? You can join just like that. Examples of each other. Right? What we're doing today in class, we're going to learn about images. I'm going to give you an object, how to obtain an image, and how to define and explain the image. Right? Draw this one kind of big, right? Draw it kind of big because I want to give you some definitions on that same diagram. Don't do with the graph papers yet, sir. Use the graph paper after this. We need a ruler to one inch. Ready? So on this convex lens, I want to give you some definitions, right? When I finish. Are done? Anybody join online still? All right, so let's take a look at this here. So there are some definitions that we need to know. Number one, what is F? F is what we call your focal point, right? That's where all the rays will converge to, right? F is your focal point. See here, the middle of your lens, that's O. The middle of your lens is O, and O is your optical center. Right? O is your optical center. See that? O to F. O to F, that's all here. O to F is what we call our focal length. Right? And this imaginary line here that going through O, that imaginary line is called our principal axis. All right? And one more definition. At the focal point, there's an imaginary perpendicular line, and that entire line is what we call our focal plane. That is called our focal plane. All right, copy that down. Yeah, copy that down. Right, you all have that? Yeah? Okay, nice. So from this now, we need to learn a few things, right? We need to learn about how to get our image. All right, so head up image. Taking off this, right? This over here. right? Let's see if you can learn about images, right? Of course, we know that once we go through a lens, right, the object should produce an image, right? What we're going to learn now is we're going to learn how to generate and how to obtain that image. Okay, so what do we need to know about an image? Right? Some of the things that we need to know are these properties here. So properties of an image, right? So image number one, an image could be real or virtual. Image could be real or image could be virtual. Right? What do they mean by real? Well, the rays meet. And if the rays do not meet, we have something called virtual. All right. So an image could be real or virtual. And if the rays meet, I'll show you what rays meet. We have it real. If they're not, they are said to be virtual. All right. So the four things that we need to learn about, we need to learn about if it's real or virtual. We need to learn about their size. We need to learn about their orientation and their position. Okay. So when I refer to size, I want to know if they remain the same size or if they are magnified or if they are minimized. Right? I want to know those three things. Orientation, I want to know if they're inverted, if they're upside down, or if they're upright. And the last thing, we need to know the position. All right? So those are the four things that I want to know about every image. Amplify, minimize. Right? So these are the things that we need to know. Is it real or virtual? Is it same size? Is it magnified? Is it minimized? Is it inverted or upright? And where it is, the exact position. All right. So we are going to use a convex lens. And instead of drawing a curve, I'm just drawing a straight line, right? That is our lens. And I'm going to draw through the optical center. What is called this line again? What is called a line on here? What is called the line through the optical center? I just give you the definition on here. Principal axis. All right. So we are going to figure out how to draw the image. Let's do some measurements, right? Let's do some measurements. Let's draw a line 12 centimeters long, and the focal length is 3 centimeters. So here to here, 3 centimeters, here to here, 3 centimeters. So here to here, 6 centimeters. Do the same thing here and do the same thing here. Right? So you can draw it a little more than 12. Actually, draw it more than 12. But here to here is 3, here to here is 3. And you can probably add on another extra. That's okay? Draw a line, make it look like this. O to F is 3 centimeters. O to F, 3 centimeters. Here's 3, here's 6, here's 3, here's 6. Good afternoon, and when you finish, Online, you're doing it. Narayan? Malia? Yeah. Right, make sure everything is exact. Right? Oh, I make a mistake. They should have gone on your graph book. Anyway, you're quite up here with this one, right? All the others put in the graph, put on the graph book. Okay, next. Here's what you're doing. You're drawing an image. This is going to be the image. Right? What I want you to do is between F and 2F, let's say about exactly in the middle. Exactly in the middle. So that'll be 4.5 centimeters right here. Draw a line 3 centimeters high. Draw a line 3 centimeters high. 3 centimeters include the arrow header. This whole thing here is 3 centimeters. That is the object. That's the object. Right, 3 centimeters high. Include the arrowhead as well, right? Include the head of the arrow as well. Ready now? So here are the rules, right? Before we do it, I want to give you the rules. There are 2 ways that we need to draw. So write this down under your diagram. To determine the image, to determine the image, to determine the image, we must draw the following lines. Rays. To determine the image, we must draw the following rays. To determine the image, we must draw the following rays. Ready? Ray number 1. Ray number 1, a line parallel to the principal axis. Parallel to the principal axis. Then through the focal point. Parallel to the principal axis, then through the focal point. That's the first ray. Parallel to the principal axis, then through the focal point. Number 2. Number two, array through the optical center. Array through the optical center. Array through the optical center. All right, so I'm gonna do this one for you. Mine is going to come out perfect because mine is not to scale, right? These things really have to be done on a graph page. All right, so watch this here. So first way, parallel to the principal axis through the focal point. Right, that is the first way. Parallel to the focal point. Next one, watch it here. It goes through the optical center. It goes through the optical center. Watch this here. Everybody watch here. Watch this here. You have to use a ruler, right? Make sure don't average like me, right? Draw a line to the optical center. Draw the one parallel to the principal axis, right? Make sure it's exact. When it reaches here, then it comes to the focal point. Where those rays meet, that is where your image will be. Okay? So you will notice that the top is here. The rays from the top meet right here. That's the image. Okay with that? Follow that? So the ray come in here. When the ray meet the lens, it's coming down to the focal point. Next one is straight through the optical center. Where they meet, that's the image. Set it up. And then we're going to answer those four things. Right? We're going to answer those four things about the image. Yeah? You all get through it up? Let's describe it now. Real or virtual? Do these rays meet? Yep, the rays meet. So therefore, our image is real. Everybody okay with that? Are you okay with that? See that? Next. Number two. Is it the same size, magnified or minimized? How it look? Magnified, eh? It look larger? It look magnified. Third thing. Is it upside? Is it inverted or upright? Anya? I mean not Anya. Annalie? Inverted or upright? Inverted. Right? Look at the object, look at the image. And lastly, I don't sure where it is, but I those who use the actual centimeters. Is it beyond 2F? Yeah. So you're writing beyond 2F. Right? You can work it out, tell them exactly where it is. How far away it is. How much centimeters from home? Might be 9. No, won't be 9. Like 7.5. How many centimeters away from home? 6.3. Right there. 7 point something in. Huh? Yeah, it's like 7.5, which but it wouldn't work out to get a polygon if we don't do it the same. Everybody okay with that? So that is the way you get the image. All these easy except for virtual, right? Let's do our next one now. Go to 2F. Same thing, same dimension. Use a graph page this time. Use a graph page, use 3 centimeters, 3 centimeters, 3, 3. And I want to see that. Online, I want to see the diagrams, right? Malia, I will see a diagram. Chelsea and Lindsay, right? Chelsea, not here. Sabira. right? Here's what you're doing from now. You're taking the 3 centimeter and you're putting it on 2F. Right? So I want you now to move the object from there. Move the object from there. And put it on 2F. All the same dimensions, right? All you're doing is changing where the object is. All right? At 2F. Draw it and define all the properties of the image. These all have got to be exact, right? Can be exact, right? I'll pass along and watch it come when you finish. Malia, you'll send a diagram. So what it looks like. Finish already? We're gonna finish already. Well, you still have beyond 2F to do and then between 2 and F. 4 we have to do. Bring it to the answer, yeah? So you're kind of wrap it. And you hear that? You have to describe it, all 4 things. Where are we just done? So that 4 things. Yeah,
All right.
right, it's 4.
Right.
Right. So you don't need something. Sure. Right, so let's just see what happened. So you went parallel here, and you went through the focal point, then you went through the optical center, then you come down here and you have the image. So there are 4 things about the image. Number 1, we know it what? We know it real. Number 2, when you measure it, it should be the same size. Number 3, inverted. Number 3, inverted. And number 4, it is at 2f, exactly at 2f. Right? It's exactly at 2f. Next one. We have 2 more to do. We're going beyond 2f now. Right? Let's go about 3, 4, about 7 centimeters out. Right? Here's about 3, 6. Let's go about 7 centimeters. Right? About 7 centimeters now. Right? That's where image is now. Do that, please. And then we'll do between O and F after. Just one more graph page, put it in 2, right? You don't need a whole graph page, right? Right? Draw your image beyond 2F. Again, good. Right? Those who online, you can send a description, right? Tian, Severa, Malia, right? Adrian, you have to send a descriptions online. Just send your full description, right? For of the image that is. Between 1 and 5. Finish? Finish all of it? 1 and 2? All right, so you had to be like exact familiar. Maybe you just draw your line a little bit more, right? But it should be exactly at 2F. No, last one. Chill talk more, last one. That one. Ijaz, trouble. Finish it already? Come away again now. Real or virtual. Right, next one. Size. Minimize. Third one. Orientation. Inverted and last one. Okay, well, between F and 2F, right here. As we get between F and 2F, very good. Very, very good. Right? So you should have real, you should have minimized, inverted, same size. Now for the hardest one. Right? Now for the hardest one, right? Draw it between O and F. Between O and F. And then you'll recognize there's a little problem happening, right? Between O and F. It's not true. Something happening. What happened? Right, so there's a slight problem. Let me just walk around and see if you all getting that problem. Huh? Same thing, same thing. Enjoy too high if I could look out there. Going on a grade and a graph data. Huh? Think about it. Look back at the divergent lens. We get something. Something has to be done. I'll do it just now. Something has to be done. Yeah, it should fit. Right? So you all may have recognized that this happened, right? When you draw it parallel through the focal point, right? And you draw it through the optical center in a meeting nerve. They didn't meet, right? So therefore, we know it's going to be virtual, but how do we recognize the other? How do we define the other things? Here, what you do? Watch this here. Watch up here, Olive. So the lines will be divergent, right? So what you just do is you draw the lines back in the next direction. It's called extrapolation. So you're drawing the line backwards here. You're drawing the line backwards here. That's okay. When you draw the line backwards, this line and this line, they will meet. Where they meet, that is your image. Right? Let's see if we can define it out. See if we can define the four things. Right? See if we can define the four things. Online messaging, four things with messaging, four properties of the image. Good job, Tian. That was the last one, right? Huh? That sounds good. Right, let's go, Anya. Come all four now, please. First one. First one is what? Huh? Virtual, good, because the ray is now metered, right? Second, magnified. Third, huh? Upright. Right, same as the, and fourth one, how you would say that? You want to give them the exact position. What you would say? What you would say? You must be able to say something, so you're trying to give somebody the directions. Or you would give them directions to find where the image is. Someone else? Huh? Beyond F, but it could be on the next side too. It could be beyond F here too. Huh? Well, say what say, you need some more specific directions. Well, Chetan, what you were saying? Beyond F on the left side. All right, I can pass. But here what you will actually say. On the same side as the other. Right? Between F and 2F on the same side as the other. Sorry, you're got it beyond 2F? Oh, you're got it between F and 2F. Between F and 2F. Between F and 2F on the same side as the other. Between F and 2F on the same side as the other. Yeah. You can put the object on. Think about it. Check it on, see. Check it on. Put the object on F and see what will happen. There's a reason I didn't do that one. You okay with that? Parallel, yeah. Those ways will never meet. So At F, no image. No image. At F, no image. That was a really good question. Right? Okay. So if you look at the little handout, you will see everything, right? You will see all the different examples based on where you put it. Here what they said at F, they said that the rays are parallel will never meet, so the images are finished at infinity. So technically, no image. Right? We didn't do this one, but take a look at it. If they have a concave lens now, if they have a concave lens, that's the way the image is obtained. That's okay, because remember what's happened to the rays? They diverge, right? So because the rays that diverge, watch this here. The one that's coming in here, it will diverge like that. So when you reach there, you have to draw the line backwards. The one through the optical center, nothing will happen to it. So where they meet, that's the image. Enough? So a little bit weird. I'm gonna show you again. When you draw it draw it parallel to the principal axis, right? The ray will diverge. But remember, we learned to draw it backwards, right? That's called extrapolation to the focal point. And then when you do that, you do the optical center to the optical center, where they meet, that's the image. You see that? Anya? Sure. You just see enough? Right? So if ever they ask, it never asked it before, but in case they ever ask it to draw it for concave lens, that's the way it will look. It'll be smaller, virtual upright. Okay with that? Everybody okay with that? All right, nice. So that's that part of lenses. One thing we have to do again, we just have to have a little idea about this formula called the lens maker formula, right? The lens maker formula, right? And magnification. So head up, lens maker formula and magnification. Lens maker formula and magnification. Lens maker formula and magnification. So everything that we've been doing on the graph paper, we can actually calculate those things using the lens maker formula. All right. So you'll have to draw this diagram, but let me just explain everything in the diagram. The distance from here to here, we call that object distance. That's it. The distance from here to here, we call that the image distance. We call that V. Right? From O to F, that's the focal length. Right? And the lens maker formula is this. 1 on the focal length is equal to 1 on U plus 1 on V. And magnification is B over U. That's it. So there are two things that we need to do. Right? Draw diagram first. Right, so that little diagram, and just to give us some definition. Right, and then do that for magnification and lenses. Oh, I think they're missing a label in. They're missing a small label in order. At this day diagram, each eye is height of the image, and each O height of the sorry, I'll label it back again. Right, each O is height of object, and each eye is height of image. Right, so let's see if this make any sense, huh? Let's see if these formulas make sense. Let's go back to our diagrams. Go back to our diagram, right? Go back to the first one on the graph page. Go back to the first one on graph page. Right? Go back to the first diagram on the graph page. So here's what we're trying to do. We're trying to use lens maker formula. 1 on U, 1 on F is 1 on U plus 1 on V. All right. So let's see what I gave you. For the first one, this was the one I think I gave you at 2f. As the first one? Right. What is small f, Lindsay? Small f was what? What was the focal length for that diagram? How much centimeters? 3 centimeters. What was the object distance, area? How far was the object from the optical center? Sure. Look at where object was. Okay, well, yours is 4 because you didn't listen. But it's supposed to be what? 6, right? No, you didn't listen. She put 2 and you use your values, right? 2 and 4. All okay with that? Right. So let's see if we can work out where the image was supposed to be at. All right. So we're using this formula. For those who are not too good with maths, I'm bringing across this here. So I'll get 1 on V is 1 on F minus 1 on U. Everybody actually be good at maths, man. Right. But okay with that? So I want to find V. So 1 on F is 1 on 3 minus 1 on 6. Do you learn maths? 1/3 minus 1/6 is 1/6, right? And then you have to flip it over. So you'll get V is 6 centimeters. What does this say? This says where the image is. The image is 6 centimeters. The image is 6 centimeters from the object. That's true? Yeah, very good. So we okay, right? Let's check out the magnification. So therefore, the image distance tells us it's at 6. So we should have gotten at 2f. That's okay? Are you okay with that? Teachers? Yeah? Let's check out the magnification now. Magnification is B over U. V is 6, U is 6. V is 6, U is 6. 6 over 6, 1. What does that say about the image? Same size. Are you okay with that? Anya, please find out where question. Are you okay with that? So we can use the formula and find any of these things. All right. So we can do it graphically or we can do it using the formula. Are you okay with that? Copy it down and do what I did with the next one. Beyond 2f. Do what I did here at 2f. Do it for beyond 2f. See if it works out. Right? Do the same thing with 2f and see if it works out. Are you okay online? Eden? You getting through? Sorry, not Eden, I mean Adrian. I think so. Try it between 1 and plus 1. Try between 1 and plus 1. Please remember, you have to flip it over. When you find 1 and 3, you have to flip it over. Please stick in those graph pages and then go. Right? For those who did the virtual, for those who did the O2F, here's what happened, right? Let's just check out the one between O and F. Right? So same thing, you have 3 centimeters here. This is 1.5. So 1 on V is equal to 1 on 3 minus 1 over 1.5. 1 on V is, what do you get? 1 over what? 9 over minus 3. Right? So you got V to be minus 3 centimeters. Okay? So this minus sign here, nothing wrong with that. That minus sign just telling us that the image is virtual. That's okay? That's what that minus sign telling us. If it's positive, it means what? It's real, right? Yeah? Well, please learn this center. The more of it always secret, but don't go on your right. Yeah?
Since it's straight up means
Negative as well. So magnification will be negative 3 over 1.5. So it means minus 2. This minus sign in magnification telling us the orientation. right? So it's telling us that the image is upright. Yeah, yeah, still be magnified. Still be magnified, don't worry with this, right? It's still twice as big, but the minus sign telling us that it's upright. That's okay? Jaden? This came this year, but it came on a graph. So I wouldn't do that, but yeah, give it a go. That's a good idea. I like what you did, so when you think about it. It's on, I like what you're saying. I thought we didn't be done. That is 2025.
2025.
2025. I know, but I can't help you. I thought I think the best I can do that. Complete the rails, find the magnification, find the focal line. Last one, are we done? And we done. We have a couple small things. We have a couple small things to do. And we'll finish up that Tuesday and finish up waves, right? And then we get nutrition. Anybody like to stay in school? Magnets. We got 30, but I do that. So we can let all be able to electricity and magnets. And start the one. The sad thing is that we can't get to do any we can't get to do anything in chat. We have no chat. But what do I get GC? You know, grandma? Huh? Hello, right. I tried to take on the entire step, but right, the buttons. But November is not bad, time to get on after that. Hey, go on, no, wow. Huh? Where is the play? For the ball? On the, huh? I know that, huh? That's one half of it. Right, during the holiday, so that's be like 3 weeks, right? July. How can be exactly? Yeah, so. So this reading might be done with syllabus by a few months. Start with start with where everything a little faster and more with the part. Yeah, did you research it? I just do like 91. I don't know. It'd be nice to be more fun as the I don't know. One teacher to get
So we can make one.
huh?
So we can make one.
Is it a little more? You have to think a little bit more. It'll be as straightforward. Look the time magnification. Be a little more fun. So I think a little bit. Take a picture and zoom in. Or you can come closer now. All these are chairs so you come and sit down. Hold on, let's let me back. How did you Alright, let's correct this out. Let me see everything there. First one, the rays will converge there, right? That's okay? Yeah, the rays converge. Next one, magnification is image height, which is 3.6 divided by 2.4. And you get 1.5. So you get that? 1.5. For the same magnification, calculate the image distance. So M is equal to V over U. So V is equal to M multiplied by U. So you're multiplying 1.5 by 20 and you will get 30. So you get that? Yeah, same formula you use it. Last part, focal length. Focal length is 1 on F is equal to 1 on U plus 1 on V. What was U again? 20. Okay. So that's 1 on 20 plus 1 on 30. Right? I'm writing it up here, right? 1 on F is equal to 1 on 20 plus 1 on 30. So 1 F is how much? 1 over 12, 1 over 12. So F is how much? 12, right? Don't forget to flip it over, yeah? Don't forget to flip it over. It's not 1 on 12. 12 is the answer. All right. So that's it for lentils. Right? That's it for lentils, right? Right, next year we'll just do a little, I think I remember reading through EM waves with all the electromagnetic waves and sound. We didn't read through that. Let's do that. I feel like I do it, but I know it's element notes. Can't really tell because I'm doing so much in the class one. All right.